ये है periodic table का ncert का solution। तो पहला क्वेश्चन कि what is the basic theme of organization in the periodic table? So the basic theme of the organization of the element in the periodic table is to classify the elements in the periods in the groups according to their property. This arrangement makes the study of the elements and their compounds simple and systematic. In the periodic table, elements with a similar property are placed in the same group. Why important property? Which important property is mainly used to classify the elements in each periodic table, and did he stick to that? So mainly by arranging the elements in the periodic table ordered by the atomic weight or the mass, he arranged the elements in the period and the groups in order of their increasing atomic weight. He placed the elements with a similar property in the same group. However, he did not stick to his arrangement for long. He found out that if the elements were arranged strictly in order of the increasing atomic weight, then the some elements did not fit within the scheme of the classification. Therefore, he ignored the order of the atomic weight. In some cases, for example, atomic weight of the iodine is lower than that of the tellurium. Since Mendeleev placed tellurium in group 6 before iodine in the group 7, simply because iodine properties are so similar to the fluorine, chlorine and the bromine. फिर आता है what is the basic difference in approach between the Mendeleev's periodic law and the modern periodic law? So Mendeleev's periodic law states that the physical and the chemical property of the elements are periodic function of the atomic weight. On the other hand, modern periodic law states that the physical and the chemical property of the elements are periodic function of the atomic number. Next, on the basis of the quantum number, justify the fixed period of the periodic table. So we have the 32 elements. So in the periodic table of the elements, a period indicates the value of the principal quantum number of the outermost cell. Each period begins with the filling of the principal quantum number n. The value of the n for the fifth period is the fixed for n by 6 azimuthal quantum number can have value 0, 1, 2, 3, 4. According to the above principle, electrons are added to the different orbitals in order of the increasing energy. The energy of the fifth d subcell is even higher than that of the seventh subcell. In the sixth period, electrons can be filled in all the 6s, 4f, 5d and the 6 subcell. Now the 6f has 1 orbital, 4f has 1 orbital, 5d has 5 orbitals and the 6p has 3 orbitals. Therefore, there are a total of the 15 orbitals available. According to the Pauli fusion principle, each orbital can accommodate a maximum of the 2 electrons, and the 50 orbitals can accommodate a maximum of the 32 electrons. The fifth period of the periodic table have the 32 elements. फिर आता है in terms of the periodic and the group, where would you locate the element with z बराबर for 14? The element with the atomic number z बराबर 87 to z बराबर 14 are present in the seventh period of the periodic table. Thus, the element with z बराबर 14 is present in the seventh period of the periodic table. In the seventh period, first two elements with z बराबर 87 and z बराबर 88 are f block element. The next 14 elements including z बराबर 89, that means z बराबर 90 माइनस 90 से 14 are the f block element होता है. ठीक है. 10 elements with z बराबर 89, z बराबर 4 से 12 are t block elements. And the element with z बराबर 13 से 18 are the p block elements. Therefore, the element with z बराबर 14 is the second p block element in the seventh period. Thus, the element with z बराबर 14 is present in the seventh period or in the 14th group of the periodic table. अगला है कि write the atomic number of the element present in the third period and the 17th group of the periodic table. So there are 2 elements in the first period and the 8 elements in the second period. The third period starts with the element z बराबर 11. Now there are 8 elements in the third period. Thus the third period ends with the z elements z बराबर 18. That means the element in the 18th group of the period has the z बराबर 18. Hence the element in the 17th group of the third period has the atomic number z बराबर 17. फिर आता है कि व्हाट डू यू थिंक लॉरेंस बर्कली लेबोरेटरी, तो लॉरेंसियम जेड बराबर 14 एंड बर्कलियम का हो जाएगा जेड बराबर 97. सियाबोरियम का होता है 106. फिर आता है कि व्हाई डू एलिमेंट्स इन द सेम ग्रुप हैव द सिमिलर फिजिकल एंड द केमिकल प्रॉपर्टीज. तो द फिजिकल एंड द केमिकल प्रॉपर्टी ऑफ द एलिमेंट्स डिपेंड्स अपॉन द नंबर्स ऑफ द बैलेंस इलेक्ट्रॉन. Elements present in the same group have the same number of the valence electron. Therefore, the elements present in the same group have the similar physical and the chemical properties. फिर आता है what is the atomic radius and the ionic radius really mean to you? The atomic radius is the radius of an atom. It measures the size of the atom. If the element is a metal, then the atomic radius refers to the metallic radius. Then if the element is a non-metal, then it refers to the covalent radius. Metallic radius is calculated as the half the internuclear difference separating the metal core in the metallic crystal. For example, the internuclear difference between the two adjacent copper atom in the solid copper is 256 picometer. Thus, the metallic radius of the copper कितना होगा 256 by 2 यानी कि 28 picometer. Covalent radius is measured as the distance between two atoms when they are bound together by a single bond in the covalent molecule. For example, distance between the two covalent atoms in the covalent atom is 1.98 picometer. Thus, the covalent radius of the covalent कितना हो जाएगा 99 picometer. फिर आता है कि ionic radius means the radius of an ion, cation or anion. The ionic radius can be calculated by measuring the difference between the cations and the anions in the ionic crystal. Since a cation is formed by removing an electron from an atom, the cation has fewer electrons than the parent atom, resulting in an increase in the effective nuclear charge. The cation is smaller than the parent atom. For example, the ionic radius of Na plus ion is 95 picometer, but the atomic radius of Na plus atom is 486 picometer. On the other hand, an anion is larger in the size than its parent atom. This is because an anion has the same nuclear charge but more electrons than the parent atom, resulting in an increased repulsion among the electrons and a decrease in the effective nuclear charge. For example, the ionic radius of the F minus F is 36 picometer, whereas the atomic radius of the F atom is 64 picometer. फिर आता है कि how does the atomic radius vary in the period and a group? How do you explain the variation? The atomic radius generally decreases from the left to right across a period. This is because within a period, the outer electrons are present in the same valence shell, and the atomic number increases from the left to right across a period, resulting in an increased effective nuclear charge. As a result, the attractions of the electron to the nucleus क्या होता है increase होता है. On the other hand, the atomic radius generally increase down a group. This is because down a group the principal quantum number n increase, which result in an increase in the distance between the nucleus and the valence electron. What do you understand by the isoelectronic species? Name a species that will be isoelectronic with each of the following atoms or the ions. So atoms and the ions having the same number of electrons are called the isoelectronic species. F minus 9 plus 1 10 electrons. Therefore the species isoelectronic with it have the 10 electrons. Some of the isoelectronic species are the Na plus जिसमें 10 इलेक्ट्रॉन है, Ne जिसमें 10 इलेक्ट्रॉन है, O2 माइनस जिसमें 10 इलेक्ट्रॉन है, L3 plus जिसमें भी 10 इलेक्ट्रॉन है. फिर Ar है the 18 electrons. Thus the species isoelectronic with it will also have the 18 electrons. Some of the isoelectronic species are the F2 minus, Cl minus ion, K plus ion or the Cu2 plus ion. But Mg2 plus is the 10 electron. The species of electronic with it will also have the 10 electrons. Some of the electronic species are the F minus ion, Ne, O2 minus ion और L3 plus ion हो जाता है. उसके बाद फिर आता है कि Rv plus ion है the 37 minus 1 36 electron. The species isoelectronic with it will also have the 36 electrons. Some of the isoelectronic species are the Br minus, Kr, Fr2 plus. फिर आता है कौन सा the following species N3 minus, O2 minus, F minus, Na plus, Mg2 plus and L3 plus. What is common in them? So each of the given species has the same number of the electrons, 10 electrons, and the given species क्या हो जाएगा isoelectronic और arrange them in order of increasing ionic radii. तो सबसे ज़्यादा N3 माइनस, फिर O2 माइनस, फिर F माइनस, फिर Na प्लस, फिर Mg प्लस और L3 प्लस. न्यूक्लियर चार्ज जो होता है सब में तो isoelectronic है, तो जिसका एटॉमिक नंबर कम होगा उसमें है जो साइज उसका ज़्यादा बड़ा होगा. ठीक है. उसके बाद फिर आता है कि एक्सप्लेन भाई कैटायंस आर स्मॉलर एंड एनायंस लार्जर इन रेडियाई देन द पेरेंट एटम. The cation has a fewer number of electrons than its parent atom, while the nuclear charge remains the same. As a result, the attractions of the electrons to the nucleus is more in the cation than in the parent atom. Therefore, a cation is smaller in size than the parent atom. On the other hand, an anion has one or more electrons than its parent atom, resulting in an increased repulsion among the electrons and a decrease in the effective nuclear charge. As a result, the distance between the valence electron and the nucleus is more in the anions than in the parent atom. Hence, an anion is larger in the radius than this parent atom. Next, what is the significance of the terms isolated gaseous atom and the ground state while defining the ionization enthalpy and electronic enthalpy. तो इसमें रिक्वायरमेंट है, हिंट है कि रिक्वायरमेंट कंप्लीशन प्रोसेस के लिए. तो ionization enthalpy the energy required to remove an electron from an isolated gaseous atom in its ground state. Although the atoms are widely separated in the gaseous state, there is some amount of the attractive forces among them. To determine the ionization enthalpy, it is impossible to isolate a single atom, but the force of attraction can be further reduced by lowering the pressure. For this reason, the term isolated gaseous atom is used in the definition of the ionization enthalpy. Ground state of an atom refers to the most stable state of the atom. If an isolated gaseous atom is ground state, then the less amount of energy would be required to remove an electron from it. Therefore, for the comprehension process, ionization enthalpy and electronic enthalpy must be determined for an isolated gaseous atom and in the ground state. Energy of an electron in the ground state of the hydrogen atom is minus 2.18 to the minus 18 joule. To calculate the ionization enthalpy of the atomic hydrogen in the term of the joule per mole. It is given that energy of electron in the ground state of the hydrogen atom is minus 2.18 to the minus 18 joule. Therefore, the energy required to remove that electron from the ground state of the hydrogen atom हो जाएगा minus 2.18 to the minus 18 joule. The ionization enthalpy of atomic hydrogen is 2.18 to the minus 18 joule. Hence, the ionization enthalpy of the atomic hydrogen in the terms of the joule per mole is 2.18 to the minus 18 to the 6.02 to the power 23 यानी 1.31 to the power 6 joule per mole. पता है कि among the second period elements, the actual ionization enthalpy are in the order. तो इसमें हो जाएगा नियॉन F, फिर N, O, C, B, F और L आ जाएगा. B है the higher enthalpy of ionization than the B और O है the lower enthalpy of ionization than the N and the F. During the process of ionization, the electron to be removed from the beryllium atom is a 2s electron, whereas the electron to be removed from the boron has a 2p electron. Now the 2s electrons are more strongly attached to the nucleus than the 2p electron. Therefore, more energy required to remove a 2s electron of the beryllium than the required to remove a 2p electron from the boron. Hence, beryllium has a higher enthalpy of than the boron. In nitrogen, the 3 2p electrons of nitrogen occupy the 3 different atomic orbitals. However, in the oxygen, two of the four 2p electrons of the oxygen occupy the same 2p orbital. This creates increased electron repulsion in the oxygen atom. As a result, the energy required to remove the fourth 2p electron from the oxygen is less compared to the energy required to remove one of the three 2p electrons from the nitrogen. Hence, oxygen has a lower than the nitrogen हो जाएगा. फिर आता है कि fluorine contains one electron and one proton more than the oxygen. As the electron is being added to the same cell, then increase in the nuclear attraction due to the addition of a proton is more than the increase in atomic impulsion due to the addition of an electron. Therefore, the valence electron in the fluorine atom experiences a more negative effective nuclear charge than the experienced by the electrons present in oxygen. As a result, more energy required to remove an electron from the fluorine atom than the required to remove an electron from the oxygen atom. Hence, oxygen has a lower enthalpy of annihilation than the fluorine. How would you explain the fact that the first annihilation enthalpy of sodium is lower than that of the magnesium, but the second annihilation enthalpy is higher than that of the magnesium? So the first annihilation enthalpy of the sodium is lower than that of the magnesium. This is primarily because of two reasons. The atomic size of the sodium is greater than that of the magnesium, or the effective nuclear charge of the magnesium is higher than that of the sodium. So for this reason, the energy required to remove an electron from the magnesium is more than the energy required in the sodium. Hence, the first annihilation enthalpy of sodium is lower than that of the magnesium. However, the second annihilation enthalpy of the sodium is higher than that of the magnesium. This is because after losing an electron, sodium attains the stable double gas configuration. On the other hand, magnesium after losing an electron still has one electron in the 3s orbital. In order to attain the stable gas double gas configuration, it still has lose one more electron. Thus, the energy required to remove the second electron in the case of the sodium is much higher than required in the case of the magnesium. Hence, the second annihilation enthalpy of the sodium is higher than that of the magnesium. अगला सवाल है कि what are the various factors to beat the ionization enthalpy of the main group elements tend to decrease down a group? The factors responsible for the ionization enthalpy of the main group elements to decrease down a group are listed. Increase in atomic size of the element. As you move down a group, the number of the cells increases. As a result, the atomic size also increases gradually on moving down a group. As the distance of the valence electron from the nucleus increases, the electrons are not held very strongly, thus they can be removed easily. Hence, moving down a group, ionization energy का होता है decrease होता है. By the increase in the fielding effect, the number of the inner cells of the electron engage on moving down a group. Therefore, the fielding of the valence electron from the nucleus to by the inner core electrons increase down a group. As a result, the valence electrons are held not tightly by the nucleus, hence the energy required to remove valence electron decrease down a group. Next, the first annihilation enthalpy value of the group 13 elements are. How would you explain the deviation from the general trend? तो on moving down a group, annihilation enthalpy decrease होता है due to an increase in the atomic size and the fielding. Thus, on moving down the group 13, annihilation enthalpy decrease from the boron to the aluminum, but gallium has the higher annihilation enthalpy than the aluminum. Aluminum follows immediately after the s block element, whereas the gallium follows after the d block element. The fielding provided by the d block electron is not very effective. These electrons do not field the valence electron very effectively. As a result, the valence electrons of the gallium experience a greater effective nuclear charge than those of the aluminum. Further, moving from the gallium to the indium, the annihilation enthalpy decreases due to an increase in atomic size and fielding, but on moving from indium to the thallium, the annihilation enthalpy again increases. In the periodic table, thallium follows after the 4f and the 5d electron. The fielding provided by electrons in both these orbitals is not very effective. Therefore, the valence electron is held quite strongly by the nucleus, hence the annihilation energy of the TL is on the higher side. फिर आता है कि which of the following pairs of the elements would have a more negative electron gain enthalpy, oxygen or fluorine? The oxygen and fluorine are present in the same period of the periodic table, and a fluorine atom has one proton and one electron more than the oxygen, as an electron is being added to the same cell. The atomic size of the F is smaller than the O. As fluorine contains one proton more than the O, its nucleus can attract the incoming electrons more strongly in compared to the nucleus of the O atom. Hence, F needs only one more electron to attain the stable noble gas configuration. Hence, the electron gain enthalpy of the F is more negative than that of the O. If F and Cl belong to the same group of the periodic table, the electron gain enthalpy usually becomes less negative on moving down a group. However, in this case, the value of the electron gain enthalpy of the Cl is more negative than that of the fluorine. This is because the atomic size of the fluorine is smaller than that of the chlorine. In fluorine, the electron will be added to the quantum number n/2, but chlorine, the electron is held to the quantum number n/3. Therefore, these are less electron repulsion in the chlorine, and additional electron can be accumulated easily. Hence, the electron gain enthalpy of the chlorine is more negative than that of the fluorine. Would you expect the second electron enthalpy of the oxygen is positive, more negative, or less negative than the first? Justify answer. So when electron is added to the oxygen atom to form the O- ion, energy released of the first electron enthalpy of O negative हो जाएगा. So on the other hand, when electron is added to the O- ion to form the O2- ion, energy had to be given out in order to overcome the strong electronic repulsion. Thus the second electronic enthalpy of O हो जाएगा positive हो जाएगा. तो second वाला positive होता है, first वाला क्या होता है negative होता है. फिर आता है भाटी द बेसिक डिफरेंस बिटवीन द टर्म्स इलेक्ट्रॉनिक एंथैल्पी एंड इलेक्ट्रोनेगेटिविटी। तो इलेक्ट्रॉनिक एंथैल्पी द मेजर ऑफ द टेंडेंसी ऑफ एन आइसोलेटेड गैसियस एटम होता है टू एक्सेप्ट एन इलेक्ट्रॉन। इलेक्ट्रोनेगेटिविटी द मेजर ऑफ द टेंडेंसी ऑफ एन एटम होता है टू ए केमिकल कंपाउंड टू अट्रैक्ट a shared pair of electron। फिर आता है कि हाउ डू यू रिएक्ट टू द स्टेटमेंट दैट इलेक्ट्रोनेगेटिविटी ऑफ n ऑन द पॉइलिंग स्केल is 3.0 in all the nitrogen compounds। तो electronegativity of an element in a variable property it is different in a different compounds, hence the statement which say that electronegativity of n in the Pauling scale is 3.0 in all nitrogen compounds which क्या है incorrect है, तो ये गलत स्टेटमेंट है। the electronegativity of n is different in Na3 और NO2 में। फिर आता है कि describe the theory associated with the radius of an atom as it gains an electron or lose an electron। तो when an atom gains an electron its size increases, when an electron is added the number of electrons goes up by 1, this results in increase in the repulsion among the electrons, however the number of the protons remains the same। as a result the effective nuclear charge of the atom decreases and the radius of the atom increases। when an atom loses an electron the number of the electrons decreases by 1 while the nuclear charge remains the same, therefore the interelectronic repulsion in the atom decreases, as a result the effective nuclear charge increases, hence the radius of the atom क्या होता है decrease होता है। Rather, would you expect the first ionization enthalpy for the two isotope of the same element to be same or different? Justify your answer। So the ionization enthalpy of an atom depends on the number of electrons and the protons of that atom. Now the isotope and element have the same number of the protons and the electrons. Therefore the first ionization enthalpy of the two isotope of the same elements would be the क्या हो जाएगा same आ जाएगा। फिर दिया है कि भाट मेजर डिफरेंस बिटवीन द मेटल्स एंड नॉन मेटल्स, तो ये मेटल्स हो गया, ये नॉन मेटल्स हो गया। तो मेटल्स कैन लूज इलेक्ट्रॉन इजीली, नॉन मेटल्स कैन नॉट लूज इलेक्ट्रॉन्स इजीली। फिर मेटल्स कैन नॉट गेन इलेक्ट्रॉन्स इजीली, नॉन मेटल्स कैन गेन इलेक्ट्रॉन्स इजीली। Metals generally form the ionic compounds, non-metals generally form the covalent compounds। Metal oxides are basic in nature, non-metallic oxides are acidic in nature। Metals have low ionization enthalpy, non-metals have the high ionization enthalpy। Metals have less negative electronic enthalpy or non-metals have the high negative electronic enthalpy। Metals are less electropositive, they are rather electropositive element, non-metals are electronegative। Metals have a higher reducing power, non-metals have a lower reducing power। फिर आता है कि use the periodic table to answer the following question। Identify an element with 5 electrons in the outermost shell। So the electronic configuration of element having the 5 electrons in the outermost subshell would be NF2 NP5। This is the electronic configuration of the halogen group। Thus the element F, Cl, Br, I और At हो सकता है। फिर आता है identify the element that would tend to lose 2 electrons। So an element having the 2 valence electron will tend to lose the 2 electrons freely to attain the lowest stable Lorentz configuration। The electronic configuration of such an element will be NF2 हो जाएगा। तो this is the electronic configuration of group 2 elements, जैसे बेटा मांगे कार स्कूटर बापरा जी। फिर आता है identify an element that would give gain 2 electrons। So an element is likely to gain 2 electrons if it only 2 electrons to attain the stable noble gas configuration। Thus the electronic general value of such an element would be enough to before this is the electronic configuration of the oxygen family आता है। फिर identify the ground group having the metal, non-metal, liquid as well as the gas at the room temperature। The group 15 has the metal, non-metal and liquid has the gas at the रूम टेम्परेचर। मेटल हो गया, नॉन मेटल हो गया, लिक्विड होता है और गैस होता है रूम टेम्परेचर पर। ग्रुप 17 में ऐसा चमत्कार होता है। फिर आता है कि द इंक्रीजिंग ऑर्डर ऑफ द रिएक्टिविटी अमंग द ग्रुप 1 element is Li, Na, K, Rb, Cs, where that among the group 17 is F, Cl, Br, I। तो एक्सप्लेन करो इसको। So the element present in the group 1 have the one valence electron which they tend to lose group 17 elements। On the other hand need only one electron to attain noble gas configuration। On moving down the group the ionization enthalpy decreases, this means that energy required to lose the valence electron decreases, thus reactivity increases on moving down the group। Thus the increasing order of reactivity among the group 1 elements हो जाएगा Cf, Rb, K, Ar, Na और Li। In group 17 as you move down the group from the chlorine to the iodine the electronic enthalpy becomes less negative, that means the tendency to gain electrons decrease down the group 17। Thus reactivity decrease down the group, the electronic enthalpy of the F is less negative than the Cl, after it is the most reactive halogen। This is because of its low bond dissociation energy। Thus the energy order of the reactivity among the group 20 elements हो जाएगा F, Cl, Br और I। फिर आता है राइट द जनरल ऑर्डर ऑफ इलेक्ट्रॉनिक कन्फिगरेशन एस पी डी एन एफ ग्रुप एलिमेंट्स। तो इसका हो जाएगा एन एफ 1 2 से 2 2 - 7, पी का हो जाएगा 2 से 6, डी का हो जाएगा डी 1 से 10, एन एफ 0 1 से 2 और एफ का हो जाएगा एन 1 से 14, डी 0 से 2, एन एफ 2 हो जाएगा। अगला क्वेश्चन है कि फाइंड दी पोजिशन ऑफ द एलिमेंट 7 आउटर इलेक्ट्रॉनिक कन्फिगरेशन एन एफ 2 एन बी 4 for n बराबर 3। तो since n बराबर 3 the elements belong to the third period it is a p block element, and since the last electron occupy the p orbital there are 4 electrons in the p orbital, thus the corresponding group of the elements number of s block plus number of t group plus number of p block कितना आएगा 16। therefore the elements belong to the third period in the 16th group of the periodic table, and the element का हो जाएगा सल्फर। पर n-1 d2 nf2 n बराबर 4। तो since n बराबर 4 the element belong to fourth period it is a d block element as d orbitals are incomparative fluid। तो there are 2 electrons in the d orbitals, thus the corresponding group of the elements हो जाएगा number of s block plus number of d block, यानी कि कितना आ जाएगा 4। फिर n-2 F7 n-1 D1 n-2 for n/6 in the periodic table. So since n/6 the element is present in the fifth period, it can be an f block element as the last electron occupies the f orbital. It belongs to the group 3 of the periodic table since all the block elements belong to the group 3. its इलेक्ट्रॉनिक कॉन्फ़िगरेशन ये हो जाएगा, द ये हो जाएगा, तो इसका कौन सा हो जाएगा, FDF712 गैडोलिनियम होता है। अगला सवाल है, द फर्स्ट annihilation of and the second of the annihilation of the kilojoule and the Eg electron enthalpy of the few elements are दिया हुआ है। तो which of the following is likely to be a least reactive element? तो element 5 is likely to be the least reactive element, this is because it has the highest first annihilation enthalpy and positive electron gain enthalpy है। most reactive metal कौन सा होगा? The element 2 is likely to be the most reactive metal, it has the lowest first annihilation enthalpy and a low negative electron gain enthalpy। फिर आता है the most reactive non-metal, the element 3 is likely to be the most reactive non-metal, it has the first annihilation enthalpy and the highest electron gain enthalpy। फिर आता है least reactive non-metal, the element 5 is likely to be the least reactive non-metal since it has very high first annihilation enthalpy and the least and the positive electron gain enthalpy। फिर the metal which can form a stable binary halide of the formula mx2, तो electron 6 has a low negative electron gain enthalpy, therefore it is a metal, further it has the lowest second annihilation enthalpy, hence it can form a stable binary halide of the formula mx2। फिर the metal which can form a predominantly stable covalent halide of the formula mx, तो इसमें कौन सा हो जाएगा, इसमें हो जाएगा element 5 है the highest first annihilation energy and highest high second annihilation energy, therefore it can form predominantly stable covalent halide of the formula mx। फिर आता है कि predict the formula of the stable binary compounds that would be formed by the combination of the following pairs of element: lithium oxygen Li2O, magnesium nitrogen Mg3N2, aluminum iodine तो Li3, silicon oxygen तो FiO2, phosphorus fluorine तो PF3 और PF5। एलिमेंट 71 विद द फुलेन, तो 71 जो होता है वो होता है ल्यूटेटियम, बैलेंस उसका क्या हो जाएगा 3, तो फॉर्मूला हो जाएगा LuF3 आ जाएगा। सही है। नेक्स्ट है, इन द मॉडर्न पीरियड टेबल द पीरियड इंडिकेट्स द वैल्यू ऑफ द पीरियड है जो क्वांटम प्रिंसिपल क्वांटम नंबर को दिखाता है। द वैल्यू ऑफ द प्रिंसिपल क्वांटम नंबर फॉर द एटम ऑफ सेल ऑफ द बैलेंस सेल इंडिकेट्स द पीरियड ऑफ द indicate the period in the periodic table। which of the following statement is related to the modern periodic table is incorrect? तो the p block has 6 columns because maximum of 6 electrons can occupy the orbitals, तो सही है। the d block has 8 columns because maximum 8 electrons can occupy, नहीं 10 column होता है, 10 column है because maximum 10 electrons can occupy the orbitals in a different, तो ये गलत हो जाएगा। फिर each block contains the number of the columns equal to the number of electrons that can occupy the subcell, तो सही है। The block indicates the value of the azimuthal quantum number L for the last subcell that receive the electron in the building up the electronic configuration। तो ये भी सही है, ये भी सही है, ये भी सही है, ये वाला गलत हो गया। ये सबको स्टेटमेंट बना के दे सकता था। फिर आता है एनीथिंग दैट इन्फ्लुएंस द बैलेंस इलेक्ट्रॉन विल अफेक्ट द केमिस्ट्री ऑफ द एलिमेंट विच ऑफ द फॉलोइंग फैक्टर्स डू नॉट अफेक्ट द बैलेंस सेल, तो हो जाएगा न्यूक्लियर मास डू नॉट अफेक्ट द बैलेंस सेल, तो न्यूक्लियर मास आ जाएगा। ठीक है, कि न्यूक्लियर मास जो होता है वो बैलेंस सेल को अफेक्ट नहीं करता है, बैलेंस इलेक्ट्रॉन को। फिर आता है फाइव ऑफ द इलेक्ट्रॉनिक स्पीशीज एफ माइनस एन एंड एन प्लस अफेक्टेड बाय, तो इसका आंसर हो जाएगा कि ये होता है अफेक्ट एफ माइनस एन और एन प्लस, किससे अफेक्ट होता है? The size of the electronic species increase with decrease in the nuclear charge. For example, the order of the increasing nuclear charge F minus Ne and N plus will follow. Therefore, the order of the increasing हो जाएगा F minus Ne and N plus will follow. F minus फिर Ne और फिर N plus आ जाएगा। ठीक है। अगला क्वेश्चन है कि which one of the following statement is incorrect in relation to the annihilation enthalpy? तो annihilation enthalpy increase for the each successive electron, नहीं डिक्रीज होता है, तो ये तो गलत हो जाएगा। ठीक है, इनकरेक्ट पूछ रहा है। द ग्रेट ऑफ इंक्रीज इन एंथैल्पी रिमूवल ऑफ इलेक्ट्रॉन फ्रॉम द कोर नोबल गैस कन्फिगरेशन, तो सही है। तो उसके बाद फिर आता है एंड ऑफ द इलेक्ट्रॉन बैलेंस इलेक्ट्रॉन मार्केट बाय बिग जंप इन एंथैल्पी। फिर आता है रिमूवल ऑफ द इलेक्ट्रॉन फ्रॉम द ऑर्बिटल्स बेयरिंग द लोअर एन वैल्यू इजियर देन द फ्रॉम द ऑर्बिटल हैविंग द हायर एन वैल्यू, तो इलेक्ट्रॉन्स में जो ऑर्बिटल बेयरिंग ए lower n value are more attracted to the nucleus than the electrons in the orbital bearing a higher n value. Hence, the removal of electrons from the orbitals bearing a higher n value is easier than the removal of electrons from the orbitals having a lower n value. तो ऑप्शन डी है जो इनकरेक्ट है। फिर आता है कंसिडर द एलिमेंट्स बी एल ए जी और के, द करेक्ट ऑर्डर ऑफ द मेटेलिक कैरेक्टर कौन सा हो जाएगा? तो हो जाएगा ऑप्शन के एम जी एल और बी आ जाएगा, के एम जी एल और बी, तो ऑप्शन हो जाएगा डी। फिर आता है कंसिडर द एलिमेंट बी सी एन एफ और एफ आई, द करेक्ट ऑर्डर ऑफ नॉन मेटेलिक कैरेक्टर कौन सा हो जाएगा? तो एफ एन सी बी और एफ आई हो जाएगा, एफ एन सी एफ आई और बी। ठीक है, एफ एन सी बी और एफ आई हो जाएगा, तो ऑप्शन हो जाएगा ऑप्शन सी। फिर आता है कंसिडरिंग द एलिमेंट्स एफ सी एल ओ एन एन, द करेक्ट ऑफ द केमिकल रिएक्टिविटी इन टर्म्स ऑफ ऑक्सीडाइजिंग प्रॉपर्टी कौन सा हो जाएगा? तो इसमें आता है एफ ओ सी एल और एन। ठीक है, ये आता है एफ ओ सी एल और एन, तो हो जाएगा ऑप्शन बी। सही है। तो यहाँ पर इसका ये चैप्टर है जो का इसका प्रोडक्टिव प्रॉपर्टी जो कंप्लीट होता है।